Here we are asked to determine the exact length of this curve. We have boxed in the arc length formula. You'll notice that this equation is written as x as a function of y, so you have to make sure you use that version of the arc length formula. That version includes dx dy rather than dy dx. It also includes lower limits and upper limits of c and d respectively rather than a and b, but basically it's the same equation. So what we can see is that in order to do the arc length, we need the derivative, dx dy. So that's our first goal, and it's going to help to rewrite the given equation before we take the derivative. So let's do that. We have x equals, now let's not forget there's a 1 in the numerator here, so you can write this as 1/8 y to the 4th. And then here what I think we'll do is take the y squared and move it up to the numerator. So we will rewrite that as 1/4 y to the -2. Notice again the exponent changes to negative when you shift it to the numerator. So that's a better way of writing out the equation. Now we need to compute its derivative. So we'll do dx dy, and we'll just use some basic power rules. Multiplying 4 by 1/8, we'll get 4/8, which of course is just 1/2. And then we'll have y to the +3. And then here you're going to multiply -2 by 1/4. That's going to give you -2/4 or -1/2. And this will become y to the -3. So there is our derivative. And what we will do now is plug this derivative, dx dy, into the arc length formula. We will also include the lower and upper bounds, which, if we recall, were 1 and 2 respectively. So we will integrate from 1 to 2. So now we have the arc length is equal to the integral from 1 to 2 of a big square root, and then we'll have 1 plus our dx dy, which we will fill in. And then don't forget that after filling in your dx dy, you have to square it. So we'll include a squaring right there, and then here we have dy. Now, before we can actually integrate, we do need to simplify this. So because we are squaring out that dx dy, it may prove advantageous to write it out 2 times. So 1/2 y cubed minus 1/2 y to the -3. And then write it out again because you're squaring it. And then what we'll have to do is actually multiply it out. It's a bit of a tedious process, but it will ultimately make the integral easier. So to multiply it out, we're going to start with 1/2 y cubed times 1/2 y cubed. That, of course, is going to be 1/4 y to the 6th. Then we have 1/2 y cubed multiplied by -1/2 y to the -3. Now, that will give us a -1/4. And then y to the 3rd multiplied by y to the -3rd. Remember, you have to add the exponents, so you'll get y to the 0, but y to the 0 is just 1. So basically, you have 1/4 times 1, which we can just leave as 1/4. So moving on to the inner terms, and when we multiply these, we're going to get a similar result. In fact, an identical result. We'll have -1/4, and then you're going to end up with y to the 0, which is just 1. So that's going to be the same thing. And then finally, here we have these being multiplied. A -1/2 times a -1/2 is a +1/4, and then y to the -3 times y to the -3 is y to the -6, because you have to add the exponents. So that takes care of multiplying that out. We still have this +1. Well, we still have a lot of stuff, don't we? We still have the square root, and on it goes. Okay, so now we have to continue simplifying underneath that square root. So 1 minus 1/4 minus 1/4. If you need to, use your calculator, but that's basically just 1 minus 1/2, and 1 minus 1/2 is 1/2. So that's just going to be written as 1/2. And let's see how we can write this most strategically. Why don't we do this? Why don't we do 1/4 y to the 6th plus that 1/2, and then plus the 1/4 y to the -6th. Now, it isn't really obvious, perhaps, how this is going to work here, but it turns out that we have a minor miracle at play here, because that expression underneath the square root is going to factor, and we'll try to show you how that works. But it will indeed factor, it looks like, to 1/2 y cubed plus 1/2 y to the -3rd squared. But how on earth do we know that? Let's not take that for granted. Let's take a little aside here. Let's see what happens when you write 1/2 y cubed plus 1/2 y to the -3 twice, which is, of course, identical to squaring it. And then we'll just multiply this out to prove that after multiplying it out, we will indeed obtain the expression underneath the square root. So here we go. Again, 1/2 y cubed by 1/2 y cubed is 1/4 y to the 6th. 1/2 y cubed by 1/2 y to the negative 3, that's just going to be 1/4 because the y's cancel. You do the inner terms as well, you're going to get another 1/4, and then you do the last terms and you're going to get a 1/4 y to the negative 6. Now, the middle 1/4, which you can barely see here, when you add those, they do indeed give you 1/2. So check it out. This expression right here that we just got after multiplying out is identical to the one underneath the square root. So it is true that we have factored this correctly. And that is awesome because that allows us to really simplify the integral. You'll notice you have the expression squared, but then it's being square rooted. So the square root and that squaring right there, they cancel each other out. This leaves us with an integral from 1 to 2 of a much simpler expression. It's just 1/2 y cubed plus 1/2 y to the negative 3 integrated with respect to y. Now we can finally integrate. So here we go. We're going to add 1 to the power. That's going to make that y to the positive 4. Multiply that by the reciprocal, which is 1/4. Don't forget about the 1/2 lingering there as well. Same kind of thing here. Add 1 to get you y to the negative 2. Multiply by the reciprocal, so that's negative 1/2. But then don't forget about the positive 1/2 that was in front there. And then this is evaluated from 1 to 2. Simplify it before plugging in your bounds. 1/2 by 1/4 is 1/8 y to the 4th minus, and it's going to be a minus, right? Because you're multiplying a positive and a negative. The halves multiply to make a 4th, y to the negative 2. All right, now we'll put the bounds in. Notice, of course, according to the fundamental theorem of calculus, we plugged in that upper bound first, and then we plugged in that lower bound second. And so now we'll continue to simplify. Here we have 1/8 times 16 minus 1/4. 2 to the negative 2 is the same thing as 1 over 2 to the positive 2, which is the same thing as 1 over 4. Over here, 1/8 minus 1/4 is negative 1/8. And then we just continue on. 1/8 of 16 is 2. We have 2 minus 1/16 plus 1/8. Then we'll just find a common denominator. We'll have 32 over 16 minus 1 over 16 plus 2 over 16. And here we have it. 32 minus 1 plus 2 is 33. So you end up with 33 over 16. And that indeed is the correct answer to the question.